Now, let us simplify radicals by reducing the order of radicals. What does it mean? It means we are going to express the index as a factor such that, or the index of the radical is reduced. Example, we have the fourth root of 64. Factor the index, we can have 2 and 2. That means we are going to write a sign which is square root here and another square root. Okay, so that we have 2 times 2 is 4. Next, we write the 64 inside. Okay, this writing two radical signs is doing the simplifying by order of radicals. And then we solve the one inside. Let's take first the square root of 64. What is the square root of 64? And the answer is 8. Very good. So we now take away or remove the one inside because we already answered it. And so we write now the radical sign, which is the bigger, and 8 inside, which is the answer to the square root of 64. And now we simplify. So square root of 8, we can factor. That would be square root of 4 times 2. And the square root of 4 is 2. And we have 2 inside, which is not a perfect square. So this is now the answer to the fourth root of 64 by using reducing order of radicals. The 10th root of 32, a raised to 5, b raised to 10. Extend the radical sign. So first, we factor the exponent 2 and 5. Okay? So which of these two factors can we use outside and inside the radical as index? So since the exponent here is divisible by 5, 5 as the inner index of the radical. So we have the square root outside, that's squared, and fifth root inside. Okay, of 32, a raised to 5, b raised to 10. Okay, extend. Change 32 as exponential. So what would that be? 2 raised to 5, a raised to 5, and b raised to 10. Okay. Simplify. The fifth root of 2 raised to 5 is 2. The fifth root of a raised to 5 is a because 5 divided by 5 is 1. Now, fifth root of b raised to 10 is b squared because 10 divided by 5, which is the index, is equal to 2. The index here is 2. And our exponent for b is 2. So we can still simplify. b goes out. And now we have the square root of 2a inside. So this is now our final answer. This is by simplifying radical by reducing order of radicals. Given 12 root of 81 x raised to 8 and y raised to 4. So, what can that be? Factors of 12 can be 3 times 4 or 2 times 6. Let's try 2 times 6 because whichever we use, we can still get the same answer. So let's use 6 as index outside and 2 as the inner index. So let's try the 6th root and then inside the square root. Square root of 81, that is 9 squared, right? And then x raised to 8, which is divisible by 2, and y raised to 4. So, now let's simplify the 6th root. Okay, and then simplify the inner radical. We have the square root of 9 squared is 9. The square root of 8 raised to 8 is x raised to 4. And the square root of y raised to 4 is y raised to 2. Okay? But we can still simplify the 6. So the 6 can be 3 times 2. So let's have cube root outside and square root inside. 9 is 3 squared. This is 2. X to the 4th and y squared. Okay. Then this will be the square root of 3 squared. So we have there the cube root. 3 squared is 3. X raised to 4 is x squared and y. So this is now our final answer. Given the 12th root of 81, x raised to 8, y raised to 4. Take note, we have the same given here. But let's solve. We're not going to use 2 and 6. Instead, we're going to use 4 and 3. Let's use 4 and 3 as factors. So that would mean, let's use the cube outside and the inner index is 4. And then we simplify the 81. That would be 3 times 3 times 3 times 3 is 81. So 3 raised to 4. And then we have x raised to 8 and y raised to 4. Simplify the inner radical. So let's have the cube root outside. 4th root of 3 raised to 4 is 3. X, 8 divided by the index 4 is 2. And y divided by the index 4 is y. So none of the exponents of the variable can be simplified. So this is already the answer. See? 2 ways of solving, but the other one is shorter. You still have the same answer,